Okay, next question. So in this one, you have to calculate the delta HF of hydrated calcium ions, which is Ca2+, from this equation using the booklet and these two processes. Okay. So we know that in order to figure out this kind of question, you have to draw the Hess law or the Hess diagram right. Okay. So the equations looks kind of misleading because I don't know where the AQs come from here. So I will just rewrite this equation. So we need to calculate the formation of Ca2+ from CaS. So we go from CaS minus 2 electrons that go to Ca2+ in the aqueous form. And they give us calcium solids that can go to calcium gas. And for this process, it is 177 kilojoule. And we also know calcium 2+ gas can go to calcium 2+ aqueous. For this process, it will release 1565 kilojoule. Okay, so if we're trying to put this on the Hess diagram, we'll see that, okay, I need to figure out the calcium gas go to the calcium 2+. This is unknown. Calcium gas can go to calcium, solid can go to the calcium gas. This process requires 177 kilojoules. And the calcium 2+ aqueous here, okay, it can be made from calcium 2+ gas. So for this one, it's minus 1565. So somehow I have to make the connection here between the calcium in gas form and the calcium 2+ in the gas form. So it looks like, if you remember, you can actually go from calcium gas. You take one electron out to make the calcium plus, and from the calcium plus go to the calcium 2+ by losing another electron. Okay, so each step here is actually the ionization energy. So to remove the first electron, it is the first ionization energies of calcium, and to remove the second electron, it is the second ionization energies of calcium. So actually, these two numbers we don't know, and they refer to the booklet. So you can find out these numbers from the booklet actually. Okay, so you need to familiarize yourself with the data booklet here. So in this booklet, you can find ionization energy, you can find bond energy, you can find atomic radii, and other numbers as well, even the periodic table. So make yourself familiar with the data booklet, you will need it. Okay, so if we look at the ionization energy chart here, and we are looking for calcium, okay? So actually, to lose the first electron, it won't cost 590, and to lose the second one, it won't cost 1150. Okay, so that's the two number that we need for our calculation. So actually 550 here and 11, what is that? 1150. Okay. Okay, so now you can see that based on Hess law, the delta H of the direct process, okay, when equal to the delta H of the indirect process. Okay, the direct process is actually the process that we are looking for, from calcium gas into the calcium 2+ in the aqueous form here. So this is the numbers that we're looking for, but the delta H of indirect process is actually all the roundabouts arrowed here, and we can calculate these numbers just by putting the number for each arrow here together. Okay, so that would be 177 plus 590 plus 1150 and minus 1565. So put all of these numbers together will give you the delta H of the reaction we are looking for, and the numbers is actually 352, and so the correct answer should be D.